This video will continue our discussion of Green's theorem, circulation form of Green's theorem, by working another example. All right, so we have this line integral over the vector field, and remember our vector field is mn, and the vector field is just the vector of that. All right, so that picks up that, and then over the c, here is my boundary here, the path I'm gonna go over. It's y equals x, which is my pink straight line, and then x squared is that purple line that's practically covered up now by my path that's in green. The path in green goes counterclockwise. So let's do I forgot to check that off, but we can make the counterclockwise thing happen. So past C, we're looking for simple. Simple means it doesn't overlap on itself. Okay, cool. Closed. All right, it starts and stops at the same spot. My region R that's inside now, it is connected. Right, I take any 2 points, no I in there, I don't know why I did that. Connected, and then simply connected. It also is that. Remember, that's any region in R can contract down to a point in R. And that region is just an open space. It's good. Nothing weird. All right, so that means I can use Green's theorem, which means I need to calculate the partial derivative of n with respect to x and the partial derivative of m with respect to y. So we take n and we integrate it with respect to x. I get negative 3y. I take m and I do it with y. The first term goes away, and then I just get left with a negative 2x squared. All right, so Green's theorem, I'm going to rewrite my problem. C 3x to the 7th minus 2x squared y dx minus 3xy dy. This is equal to the double integral over region R. And then I just subtract these things, so it's going to be negative 3y plus 2x squared dA. All right. Looking at my region, I think let's do our bounds here. Y is going to be easier to bound with functions. X is going to be easier to bound with numbers. Y goes from x squared up to y equals x. And then x runs from 0, and then those two things intersect when x is 1. We're so used to that problem. I hope you know that by now. This just shows up constantly in calculus, that little sliver. So we have that, and we can now write our bounds. X equals 0 to 1. Y is x squared up to x of negative 3y plus 2x squared dy dx. It's a nice, pretty integral. That will lead you to an answer of negative 1 over 10. All right, so Green's theorem, when you can use it, is very nice. I think these are the easiest calculations out of this whole chapter. It does get more complicated once we bring the path out of xy plane. That will be covered in later sections.